Recording. Yeah. Thank you so much, everyone, for joining. This is the first masterclass for the NHCX Hackathon. I now invite Director IT of NHA, Nikhil sir, to start us off with his opening remarks. Sir, can you hear us?
Sadhana, can you please share your presentation?
Morning, everyone. Am I audible?
Yes, sir, we can hear you.
You are audible.
Sadhana, am I audible?
Yes, sir, we can hear you. We can hear you, sir.
Sir, we can hear you.
Good morning, everyone, and thank you for taking the time to join us today. Let me introduce myself. Myself, Nikhil, Director IT, National Health Authority, and we are very excited to conduct the NHCX Hackathon. As we are all aware that National Health Claims Exchange has been live and working towards the mission of making the health claims journey simpler, faster, smarter, and interoperable and transparent. So I can say this NHCX Hackathon event, it is not just a technology event. It is an collaborative effort to solve all on-ground and operational challenges which are being faced by insurers, hospitals, providers, and HMS players and integrators. What are the problems they are encountering on day-to-day basis? So the major effort of conducting this NHCX Hackathon is to bring everyone together to a common platform so that the operational issues can be resolved and the NHCX platform can be kicked off smoothly. So at the heart of this hackathon, there are problem statements directly drawn from the ecosystem. So whatever the problems are being faced by the participants of the ecosystem, like providers, that is hospitals, other side insurers or HMA solutions. So we discussed with our partners and we brought up the important problem statements which are being faced by the NHCX ecosystem. So we aim to spark the industry-wide collaboration, co-creation of practical and scalable solutions. So that will help us to realize the vision of NHCX in the longer run. So we are honored and supported by the host of partners. So where IIT Hyderabad and GIC, that is General Insurance Council, NAT Health, and NRCES, that is National Resource Center for EHR Standards, Google, and NABH and India Insurance Tech Association. They are partnered with the NHA to make this NHCX Hackathon into a big success. And we are also very happy to announce a very big, good prize money amount, which I can't formally declare right now, but it will be a very good, decent amount, which we will announce it formally very soon. And we are very much excited to build these solutions with you. So let us use this opportunity to learn, innovate, and create something valuable. So I request Joe, NRCS, and Ignesh from TCS, Farouk, and everyone. So let us utilize this masterclass and let us, the participants, also make best use of the masterclass to understand what is exactly the NHCX, what are the problem statements. So that the participants will be clear from their angle what exactly NHCX ecosystem needs. So that is very much important. The communication is very much important. Like we have to give that clarity to the participants. And this is from my side, and I request Sadhana to take over and further lead this program.
Yeah, thank you so much, sir. We're all incredibly excited as well. Without further ado, let's jump right into it. Yagnesh, sir, I think I'll hand it over to you to give us a brief overview of NHCX and the vision behind it and the goal given as the tech architect. I'll just share my screen. Yeah, are you able to see the screen?
Yeah, Sadhana. Thank you.
Yeah.
Hi, very good morning. Myself, Igneshwara Machirla, a core architect for National Health Claims Exchange. Thank you all for joining the very first NHCX Masterclass session today. Let me begin with a simple
Sadhana, can
truth.
we know how many participants today, other than our partners? How many participants joined the
We have about
Masterclass today?
64 participants
Total
on the
just
call.
64. Okay.
Yeah, we have about 64 participants on the call, of which some of them are our partners.
Okay.
Yeah,
Can I
Yagnesh,
say?
so you can continue.
Yeah. So to start with, right, let me begin with a simple truth that we typically see whenever we go to hospitals, right? Claim processing today is fully fragmented and very costly. I hope we all agree on this, right? So this is a ground reality, of course. Let me give you an example. Okay, then we can actually correlate what we are trying to do as part of NACX. Imagine a hospital treating three different patients in the same ward, all undergo the same procedure, but one patient is under Pradhan Mantri Jan Arogya Yojana scheme. One patient may be a private insurance party, another patient may be another insurance company. So now what happens in hospital? The hospital billing team logins into three different portals, fills three different formats for claim submission, uploads documents in three different ways. And to check the status or whatever it is, they have to track in three different portals again. Same treatment, same doctor, same billing team, but three completely different claim journeys. Right? This is what fragmentation, and this is what very expensive in nowadays at hospitals. So now consider another example. A claim of 85,000 rupees is submitted by hospital. The insurance company raises a query, provide justification for ICU stay. But the query comes as an email document or a PDF attachment comes from their own IT software. The hospital downloads it, reads it manually, prepares the clarification, and uploads the documents again. There is no structured query type. There is no standard response field. There is no proper SLA tracking. So multiply this with 500 claims per day or 1 lakh claims per year. So now the scale is, you just imagine the scale at nationally, right? This is why the operational cost increases at all the stakeholders, either it is at hospital or insurance companies or regulatory bodies. So now let us talk about our vision, right? So we envision something very simple. One rail, many claims. So think of Indian Railways, the thousands of trains, different destinations, different speeds, but all run on the same railway infrastructure. Correct? The same principle applies here. In health insurance, thousands of claims, different insurers, different schemes, all should travel on the same standardized digital rail. This is what we envision as part of NHCX. So instead of hospital talk or upload the claims in different portals for different insurance companies, we move to hospital talk to one NHCX, one National Health Claims Exchange, and NHCX talks with multiple insurance companies. One integration, one standard, many claims. So now imagine a claim submitted to NHCX. The data comes in a structured format, which is a standardized diagnostic codes with standardized procedure codes, structured building components, and properly referenced attachments. Once the data is structured, so you can imagine there could be many wonders that we can do, right? So the automation, auto adjudication, the quick disbursement of the settlements, everything can be possible. For example, if the standard cataract surgery claim, it's a low cost surgery. I'm just referring as a low cost surgery so that you can actually imagine the kind of things that we can do.
Is it my internet or is Yagnesh sir stuck?
Yeah.
Okay.
With multiple specialty doctors. Let us say cancer treatment, right? Or heart transplantation, or any transplantation in that scenario. So these are all complex cases where it definitely requires a manual intervention of specialist doctors at both the sites. So it improves operational efficiency at all the stakeholders involved, right? So now let us talk something about suspicious or fraud cases, right? So in current systems, since we don't have structured information, it is likely impossible to do the fraud. Of course, we do the fraud by putting so many systems in place. But in fragmented systems, the fraud detection is difficult because the data formats are varied. They are not same, right? I cannot define any pattern, or I cannot define any protocol, or I cannot define any model. So when I have a data follows different patterns, so I cannot enable any fraud engine on top of the data, right? But when structured claims flow through a standardized through gateway, the analytical engines, they can detect anomalies. For example, usually the high ICU billing, repeated abnormal procedure combinations, because certain procedures, right, you cannot combine with other. So you can actually see the abnormality in raising claims for repeated procedures. There is a pattern-based suspicious claims. So the fraud can be prevented or flagged immediately. So now let us consider the timelines that are required to settle the patient. Today, most of the claims settle maximum in 15, 20, or 30 days, right? Due to repeated queries or rework. With standardized validation, fewer rejections, and automated adjudication, the turnaround time that can be reduced drastically. So it improves, of course, hospital cash flow because they are getting they are getting paid immediately. They can also add more hospital beds to treat the insurance patients. They can have a financial sustainability, right? Similarly, for insurance companies also, they can reduce operational costs. They don't need to keep too many adjudicate officers, doctors to adjudicate the claims. So what does NHA Gateway does? It standardizes the claim data formats, the processing workflows, the life cycle of the queries, and the whole interoperability across the systems. So once the ecosystem speaks one language, so innovation becomes possible. That is where, okay, we are now trying to invite you people to find the problems, since we are now going through the whole the entire documents coming through a standard document, so we can actually create innovative solutions, right? You can define your models. It could be a model, whatever it is, or rule-based models. So you can also detect certain ailments which can be covered or which can be given. So there are various dashboards that you can pull at national level, right? So the standardization is not that one goal that we are trying to do. We are actually trying to build a foundation for the entire health eco health ecosystem. So go to the next slide. So to achieve, right, we have to have one platform. So whatever we speak, so to realize, so we need to put some platform, right? So in this slide, I will briefly explain the technical architecture of NHCX and the various key stakeholders who are actually involved in this ecosystem. At its core, NHCX acts as a standard claims exchange between the provider systems and payer systems. So let us first understand the stakeholders. The very primary stakeholders are the policyholders, means the beneficiaries, who ultimately expect faster, transparent claim settlement. Another one is health providers, the hospitals, clinics, and laboratories. And we have included digital solution companies also, as they are the people who are supposed to build the systems, okay, to meet the ultimate goal. The HMIs vendors, health tech platforms, claims management systems, insurance claims and TPS, who actually adjudicate and settle claims. And of course, regulatory bodies such as IRDI, NRS, NHA, who actually require oversight, analytics, and the governance visibility. So now let us look at the architecture. The NHS architecture follows, it's like a hub-based exchange model, okay? The provider systems like HMI systems generate structured claims data. Instead of directly interacting with multiple insurance companies, they submit claims to payer systems through NHCX using the standardized APIs that are published. There are broadly two types of APIs that we published. We typically call them as payer side APIs and providers APIs. So the payer side APIs are nothing but the APIs which are going to be consumed by hospitals to submit pre-authorization requests, claim requests, of course, to respond queries to the payers, and of course to receive the claim status. Same way, the provider side APIs, where these are actually consumed by payer systems. For what? To raise structured queries, or to approve or reject claims, to notify settlement details. The NHCX gateway ensures that all the claims follows standardized schema and lifecycle management before reaching it to the appropriate layer. So when I say we do lot of checks in an NHCX gateway. So if you see the bottom, we have certain registries, right? So the hospital will be validated against a registry called HFR. The beneficiary will be validated against FHIR, right? The participant will be validated against the registries like we check the roles of the participant, okay, whether he's a provider or a payer or a researcher or the governing body or whoever it is, right? So we actually do all kinds of access control, security, everything at NHCX level. So before it goes to the payer systems. So all these APIs are accessible through ABDM compliant access control mechanisms. If you are registered with ABDM ecosystem, means you get actually some client ID and secret key. Using that key, you can actually start playing with the APIs that we expose through NHCX gateway. So these are all securely identified. We do role-based access mechanism. As I told, if you are a provider software vendor, and if you are trying to consume the payer side APIs, you cannot. System will throw an alert saying, okay, you are not authorized to view, right? So we have various checks and balances at NHCX level, so that, okay, the authentic data from the authentic person will be sent to the required payer system and vice versa. So each entity participating in NHCX must be registered as participant with clearly defined role. As I told, provider, payer, researcher, or regulatory body, or whatever it is. So for example, So as I told, the providers can submit and track the claims. The payers can submit the adjudication remarks, like approval remarks or rejection remarks or query remarks. And in case of regulatory body like NHA or IRDA, they can actually get aggregated results, aggregated data. Because though the NHA or IRDA cannot read the whole health information of the claim, but they can understand, they can know how many claims that are being submitted from hospital A to payer A, for which package, or okay, for which ailment that is submitted. So we have defined our protocols to cater certain requirements of regulatory body. So as per the protocols, you can see a lot of attributes, right? So now ultimately, so what it does, what it enables, okay, it enables interoperability across heterogeneous systems. It reduces integration complexity, because we are dealing with one standardized specification. Either it could be a technical specification or domain specification, and we exchange very structured information. We can automate the whole adjudication system, since we are getting the structured information from the providers. And of course, we can enable fraud analytics on top of the data that we receive, because it is structured again, structured information again. And of course, regulatory oversight, the visibility is very much available as part of this whole system. So go to the next slide. So as I said, right, the NHCX actually provides a standardized communication protocols, right, between providers and payers. So in this slide, I would like to focus on one critical aspect of NHCX. That's the standardized communication between providers and payers. So just again, so for years, right, one of the biggest challenge in health ecosystem, health insurance ecosystem, it is a miscommunication and uncertainty. When I say miscommunication and uncertainty, so how many people really know that you are entitled or you are eligible for a given ailment for this particular policy? We don't know. We simply believe whatever hospitals say, right? So as and when I give my policy, they say you are covered or you are not covered. Okay, that is also fine. But they say this particular service is not covered. This particular consumable is not covered. This particular medication is not covered. How do you know that you are really not covered or not? This is uncertainty that we want to eliminate. We do not want any uncertainty, not just only at hospital, even for beneficiary. Before he goes to the hospital, we want to know, we want beneficiary know that, okay, he is entitled, he is actually eligible for so-and-so treatment. And hospital need not, okay, ask any cash. So that is a level of confidence that we want to, trust that we want to build as part of this NHCX system. So the providers typically, it is not only for beneficiaries, even for providers, right? So providers, what typically they do currently, they raise a pre-authorization, they get a provisional approval. But after a few days, okay, they do a lot of treatments, right? They actually add more medications, more investigations. But when it goes for payer, they will realize that, okay, this particular ailment is not covered. So now what hospitals does, they will go to the patient and then say, Bhaiya, this is not covered by your policy, you please pay. So there is a rift again. So again, we do not want any such conflicts between payers and providers, and of course, beneficiaries. So what exactly is covered? What documents are required? So there is another challenge also, right? So typically when hospitals submit a claim, they submit a claim as per the, as I told, right? So they have one billing team, but multiple insurance companies, multiple insurance portals. They don't know which portal requires which protocol. One payer may say, okay, you please submit, okay, 3-4 documents. The another payer may ask, okay, additional documents, which we don't know, right? So we want to know what exactly that is required for a given ailment to submit or to get the claim approval done. So what data fields that are mandatory? Why was the claim partially approved? How do I know all these things? So this uncertainty increases friction, always delays the settlement, and adds ultimately operational cost at again both the sides, right? So the NHCX addresses this whole the problem through a structured, standardized digital communication. So let me explain the very fundamental benefits. So as I told, right, so eliminating uncertainty around coverage through digital policy. So if you see the whole journey, right, so there are use cases like coverage eligibility, pre-authorization claim, payment notice and all, but there is a very interesting, very fundamental requirement of this whole process, right, knowing your policy, right. So there is an API that we exposed, get insurance policy, get insurance plan. So this actually traditionally, see how it is, how it happens in a current system. There is a PDF document, right? So insurance policies are long PDF documents, and no one can even read it. We simply sign it, or okay, they simply accept it, and with lot of complex terms and conditions, and even to read the whole document, understand the terms, it is next to impossible for a beneficiary, of course, even for the hospitals, right? The interpretation varies between hospital building teams and insurance adjudication teams also. So with the digital insurance plan structured within NHCX ecosystem, it actually covers all the details, the ailments covered, the inclusions, exclusions, and for a given ailment, what are the mandatory documents that are required to submit as part of pre-authorization, as part of claims, as part of query, right? And it also tells you the limits. When I say limits, right, there are procedures, there are services where, okay, you can only claim once in a year or once in a life, or there are certain rules that are defined in the policy. For example, there is a secondary care treatment, so there is a limit capped. For example, for this policy, under this policy, you can claim up to 50,000 rupees as secondary care. So how do I know that, okay, that particular service is a secondary or not? So they simply upload, and then when it comes back from the provider, payer says it is not covered because the beneficiary already exhausted the secondary limit, right? Secondary valid limit. So all this information, okay, you will actually get through this insurance plan. That is a first part. Okay, we insisted all the payers to enable it, and all the integrators, means provider systems, to consume and then populate their IT systems with this metadata, with this data, so that the hospital systems can pre-check before they submit, so that, okay, they can very much ask patients, okay, these are the elements that are required for the treatment, but out of these 5, only 3 are covered, 2 are not covered. So these 2 cost around 10,000 rupees, right? So this information can be obtained, okay, in advance without any manual intervention or without reading any physical document. That is where, okay, the communication goes from payer to provider and payer to payer. So, and also the whole the ecosystem, it actually moves from assumption based to rule based. So when I say assumption, right, because when there is an uncertainty, when I don't know that the elements that are covered, I cannot read, I don't have time to read, I cannot actually know if I submit whether it will be approved or not. Lot of uncertainty, lot of trauma at my mind, everyone's mind, right? So to avoid, okay, when you have this data, so it is easy. So you can easily check, get things done without any limitations. So that is where, okay, we actually planned as part of this standardized communication protocol. And of course, as we are standardizing the whole communication protocols, we also has to standardize the communication data sets, right? Where we have proposed to use FHIR profiles, and these are all FHIR standard profiles for each and every use case that we deal with. Every API has a domain object, which is going to be a FHIR profile, and NHCX has published all the profiles. You can go through, of course, you can know better details on FHIR structure, FHIR details and all, if you go through the documentation. So, ultimately, when I say the standard communication between payers and providers, we are actually talking about certain APIs we have published. There are the profiles that are published again to communicate, and of course the communication protocol, how we are going to make the bundle, and how are you going to encrypt the bundle. So everything is detailed in the documents that are available in the system. So go to the next slide.
The next slide is benefits, which I think you've broadly covered.
Yeah, exactly. So let me reiterate everything. So we have spoken about architecture, we have spoken about APIs, but not in detail, because in detail you actually get through the detailed information from the portal. And of course, we have spoken about FHIR. You will actually hear from NRCS team in the next slides. So let us step back and ask a bigger question. So what does NHS truly deliver for each entity, as I told, for beneficiary, for hospital, for insurance companies, right? So beneficiary, as I told, okay, he can get whatever benefits that he want to. He can pre-check. He can actually get the status on his mobile, right? If hospital submit also, okay, he can see whether the claim is submitted by the hospital or not. You don't need to listen hospital people nowadays. No, because you have NHS compliant mobile app where you can actually see your own claim, where exactly it is pending with. The same way hospitals, right? Ultimately, since their systems are integrated with NHCX standard protocols, they are using only one interface to submit claims. They can reduce lot of operational costs, and of course, they can get the claim responses in a structured manner where they can understand the education remarks without any ambiguity, without any challenges. Same way for insurance companies, they get the claims in a structured format. They can adjudicate claims without any manual intervention for high volume, low cost claims. And of course, you can implement, since the data is coming structured manner, so you can implement everything, whatever is possible, whether it is a complex claim or okay, normal claim. But yes, so start with, okay, we are trying to put for high volume, low cost claims. You can do fully automated. There is no gap. And of course, we have so many ideas. Okay, I mean, of course, we are inviting you guys to provide ideas, because once you have systems in place, once you have standards in place, once you have everything is in place, right? You can design, you can put your ideas in place so that we can design better solutions for all these three stakeholders. So I don't think, okay, the queries will be there, but any queries you can post to us. We will try to answer all the queries. And of course, I strongly recommend you to go through nhcx.abdm.go.in portal, where we have a tab called documentation, where we have given all the technical documents. So you can refer it. Yeah. Thank you, Sadhana.
Yeah, thank you so much, sir. Just to add to that, we have the website which has all the technical specifications. It has been added on the NHCX Hackathon website as well. Now I think I invite NRCS and Google to take over for the primer on FHIR.
Okay. Hi, everyone. This is Chandrasekhar. I'm a software engineer from Google. So I will give a brief introduction about what is FHIR. Can you go to the next slide? Next slide, please. Yeah. So what is FHIR? So FHIR actually is a standard specification which is defined by HL7, which is used as a common language by different healthcare systems to exchange data. So in an understandable, machine readable format, right? So if you see what is actually FHIR, F stands for fast, which is very fast to adapt and model. Like a standard web developer, right, can take read the specification of it and then start developing applications using FHIR from day one itself. And it is built for healthcare domain. Like healthcare domain is complex. So the specification is mainly built for healthcare domain. And interoperability, this is ultimate goal. Like different healthcare systems want to exchange data in an understandable format, and this is the ultimate goal of FHIR. Right? And the data, if you see the data, it is broken down into smaller resources like patient resource, medication resource, observations, to capture the individual medical entities. So you just probably stick together like how you will stick like using Lego bricks, right? You can stick all these FHIR resources to capture any clinical event. Now, why was this FHIR created? Right? If you see earlier, there were like older technologies like HL7 version V2 and CDA technologies. So these technologies were rigid, right? They were highly customized, and then they were very massive, rigid. So it was difficult for the modern web applications systems to adhere to this. So FHIR was created basically to solve some of these limitations. So it is the next generation standard that is designed to solve these modern data generation needs. Next slide. Yeah, talking about the interoperability, right? So we can consider a scenario wherein, let's say, a patient visits multiple hospitals, right? So let's say he goes to one hospital, undergoes a treatment, right? Now, let's say he visits another hospital. If the data is not exchanged with the second hospital, let's say if he can carry over the medical documents in papers, but if it can be digitally exchanged, right, in an understandable format by the hospital too, then the patient doesn't have to repeat the same entire history again to hospital too. So this is where FHIR comes in, where it is highly interoperable. If the medical healthcare systems, right, the hospitals can follow this common language, it's very easy for the data transmission. Yeah. Next slide, please. Talking more about FHIR, right? Uh, so if you see, it's basically a RESTful API, and the core communication engine, right, is designed to talk like to exchange the data in a very lightweight format with the more modern formats like JSON and XML. And it consists of like a lot of open source tools which comes at ease of like free of cost and easy to build. And if you see, there is a large community behind this with many implementers as well. And like you can see, like thousands of developers, even clinicians and health IT professionals who are collaborating vastly on this. Next slide, please. Yeah. Okay. So if you see, like one of the smartest decisions of how FHIR handles healthcare data is that, like, unlike the previous systems, it doesn't try to include every possible data into one particular specification. So FHIR takes a little different approach, like the 80-20 rule. So where you say that where FHIR specification, right, the base specification focuses mostly on 80%, like 80% of the data which most of the systems need worldwide. And how about the remaining 20%, right? So healthcare, if you see, it's like a lot of local regulations might also be there. So for in order to make sure these regulations, local regulations, are handled very elegantly, right? FHIR comes up with something called extensions. So like uh, you can extend FHIR to define to accommodate all these local regulations. For example, if you take a patient, right? FHIR defines a base specification resource which captures most common details like name, date of birth, age, etc. But let's say for when we are building an application for a particular public health use case, let's say, right, and we want to capture nationality as part of that, you can simply extend the FHIR specification for patient and then include the nationality for that. So in this way, you don't have to break the system without forcing everyone else to adhere to it. You can only extend for yourself. This is how, let's say, even ABM or NHCX profiles, right? If something is very specific for Indian origin, right, you can they would have extended it and then defined customs fields. Yeah. Next slide, please. So where does all this actually live? So you can see the details over here. Like you can go to hl7.org/FHIR. You can see the official FHIR specification there. So it is completely open source and lives entirely on the web itself. So if you see the portal, right, it's a modern portal built like using hyperlinks. You can easily click on any hyperlink, for example, patient observation, and you can see all the details over there. Next slide, please. Yeah. So coming to the data models, you can see like FHIR has like more than 200 resources, and this list is keep on going in. But you don't have to rely on all these resources. For example, let's consider one scenario wherein a patient visits a clinic, right? So we can just start with one of the base resource called the patient resource, capture all the patient demographics in that resource. Then you create an encounter resource, which will basically capture the visit to the clinic, like who is the treating doctor, when and where it happened. And let's say the doctor takes a reading, right, for blood pressure, let's say. Um, you can actually create an observation resource and which holds the actual clinical reading there. So all these bundled together, right, contributes to one clinical event. Yeah. Next slide, please. So let's break down what go into each FHIR resource actually. So it mainly consists of these four blocks, right? The first one being the metadata, which is like a shipping label on a package that will basically capture the identifiers, right? And narrative, like this is the plain text which is in a most human readable format, right? This is put here because let's say if the receiving systems fails to parse the message, right, the machine message, the doctors can still open the message and then read this narrative, and then can then treat the patient. And then comes the extension. Let's say if something doesn't fit in the base 80% specification, you can extend it. Then the body, which is the core elements. So these are like actual structured data which are machine readable and which contains all the clinical and administrative details like gender, birth rate, test results, etc., right? And so this is the FHIR block which the systems use to exchange informations. Yeah, next slide, please. So if you see, this is a snapshot straight from the FHIR website for which shows that this is a blueprint for a patient resource. So you can think this as a universal checklist for patients, all the details. So you can see details like identifier, name, gender, birth date. Like, so these are some of the core points which are actually needed for most of the healthcare systems to track a patient detail. So you could also see details like numbers, right? Like 0 followed by an asterisk for each field. So this is simply FHIR's way of telling that how many items for this field are actually needed. So for example, for patient, you may say that if it is 0 dot dot star asterisk, right? It says that you need like 0 or more items for the phone numbers. So that's how the specification says. Next slide, please. Yeah. So this is one of the example of a FHIR patient resource represented in FHIR format. So you could see all the details that we discussed so far put here. Uh, yeah, yeah, right. Yeah, terminologies. So we want all the healthcare systems to understand each other, right? When they talk with each other. So terminologies form the backbone of that interoperability, right? So instead of sending free text notes, right, between computers, we rely on what is called as coded concepts, right? So So what we do, we basically represent these clinical values in machine readable codes. Like for example, for representing lab results, we use LOIN codes. For representing clinical findings, we use SNOMED codes, right, etc. So so these coded concepts come in rescue so that healthcare systems can represent data in that format and can also understand. This is universal format, so that they can understand easily. Next slide, please. Yeah, value sets. So value sets is nothing but you can assume that it is basically, instead of picking data from million possible text, right, for a particular field, you can constrain them for a specific data fields of data. For example, if you see like gender, right, you can only constrain each for to capture this field. You can say like it should be only one of these fields, male, female, other unknown, not anything else. So this is one of the specification by FHIR. Next slide, please. So how does the FHIR data looks like? How does it actually move between systems, right? So this is using FHIR RESTful APIs, and we know like this is a standard language which is used in the internet today, which all our mobile banking apps or like social media apps you leverage for exchanging informations right between systems. So we are not reinventing any wheel. We are just using already laid out standard platform, right? Um, so what the biggest benefit is speed and simplicity, right? Like um, any modern applications can easily build it, right? Yeah. So if you go to the next slide, yeah, this talks about the Fire Search API. Um, so if you want to basically search for a list of patients in any Fire server, right? You just form a REST URL and pass this particular filters in the URL, and automatically the Fire server gives you all the details. Okay. So any system Fire server who says that I'm implementing so and so API should follow the Fire specifications that are laid out by the Fire Search APIs. Okay, next slide, please. Now let's take one concrete example of how we can transform the data, clinical data or healthcare data into FHIR. So if you see this picture on the left hand side, we have a flat lab report, right? Which is basically which is kind of a PDF document. On the right hand side, we see the FHIR approach of representing this lab report. If you see like it is broken down into like 5 different data blocks, right? Let's say the high level block is a diagnostic report, which itself represents the lab report. It holds basically all the linkages to other 4 documents. Next, you can see the patient's information represented in patient resource. Similarly, practitioner resource for the doctor, right? Treating doctor. And then to capture the lab results or the test results, we have the observation resources. For example, the glucose level goes into one observation, the HbA1c goes into another observations. So all these can be bundled and then transmitted as one single FHIR bundle when you want to transmit one particular lab result. Yeah, so this is about FHIR. I think Sayali will talk more about how ABDM or NHCX has adopted FHIR in India. Yeah, over to you, Sayali. Yeah.
Yeah, sure. Thank you, Chandrasekhar. So next we will have a brief introduction where how this FHIR is adopted as a standard of exchange in India, and that too in ABDM and NHCX, which are our national digital health missions. So let me introduce myself. I'm Saili Satokar. I'm from National Resource Center for EHR Standards India. Basically, it is a standard center of excellence established by MOHFW to help implementers adopt EHR standards for India, which are notified in 2016. And for adoption of standards when it comes to FHIR, we have NRCS has hosted a FHIR implementation guide for ABDM and NHCX. So let's go through how adoption of FHIR in India has happened through ABDM and NHCX. Next slide, please. Yeah. So when we talk about FHIR artifacts, we have developed some of the profiles for FHIR. And there were 2 use case scenarios that we have. One is a Ayushman Bharat Digital Mission, and another one is a National Health Claim Exchange protocol. So when we were trying to design a FHIR artifact, so when you look at the FHIR base specification, so base specification provides you all the information, all the resources that represent an actual real world entity like patient or organization or any condition procedure. So for that, it has a resource to represent that real world entity. And when you look at the base specification or the information available, or the elements in the base specification are optional. They are not mandatory. So in order to adopt it for a specific use case, when it comes to ABDM or NHCX for India, we need to modify those specification, base specification, and we need to, put some constraint, put some rules over that specification. And like that, we have like designed profile for ABDM and NHCX. And those profiles are now available through the implementation guide, which is hosted by NRCS. Okay, so when you look at the design aspects for ABDM and NHCX, we have two use cases where ABDM actually more focusing on exchange of document artifacts. So whenever a patient goes to some hospital provider, he gets a document representing his health condition, representing that encounter, whether it is inpatient hospitalization, it gets a discharge summary as a document. Okay, if he goes for OPD encounter, it gets a prescription and OP consultation note as a document. So for ABDM, our focus, our goal is to design to have a structured artifact, FHIR artifact that represent the actual document that patient carries when it visit any specialty or any hospitals. So the more design aspects or design methodology was to represent a document artifact to a FHIR model. Okay, now when it comes to NHCX, where actual where there was a need of having a standard structure which actually represents the claim workflow, claim processing workflow. So here the exchange has happened. Exchange is happening as a based on a request response basis. It was there was a specific workflow that is there to process that data. So the design methodology that we were focusing was having a multiple workflow scenarios that we wanted to cover in NHCX. Next slide, please. So based on that, we have designed few of the artifacts for ABDM profile for ABDM as well as NHCX. If you look at the screen at the right side, you can find a FHIR implementation guide for ABDM, which is based on FHIR version R4.0.1. Okay, so base resources are we are referring to the base specification of R4.0.1. So here in implementation guide, we have around 8 ABDM profiles which represent multiple document artifacts, and around 6 clinical artifacts, 7 clinical artifacts, and 6 health claim exchange profile to depending on the workflow that we have considered for claim processing. There are multiple profiles for NHCX, and to have a so these the FHIR is followed or adopted as structure standards, which actually encapsulates all the data required, healthcare data required for that particular use case, and it gives you the which actually encapsulate that data. So FHIR is adopted as a structure standard, and to have a semantic interoperability, we have different terminology standards. So we also have SNOMED City, LOINC, which are actually a primary terminology standards notified in EHR standards for India. So where there is applicability of any terminology standards, so we have value sets which gives you the complete exhaustive list of what all values that can be possible for a particular information, like Chandrasekhar has given example of gender. So we have a particular code system, a standard international code system associated with that value set. So that is defined with multiple terminology standards. Next slide, please. So when it comes to ABDM artifacts, so we have these many artifacts available right now. So now every artifact had some structure, defined structure. Overall, every artifact will have a metadata associated with that artifacts, which covers the information regarding patient, which is represented by subject, then its encounter, custodian, then care provider information, who is author of that document, and along with a structured data that computer can process, and that can be exchanged with the help of any communication between two provider systems. So now when you look at the diagnostic report or any discharge summary, it covers metadata and what all clinical information it includes. For each information, there is a section attached with it. Excuse me. Yeah, so you can find all these record structures available on the ABDM implementation guide that I will walk you through. Next slide, please. When it comes to National Health Claim Exchange, so we have artifact defined on the use cases and the workflows. So a use case where coverage eligibility needs to be checked, pre-authorization or claim submission is there. Based on that, there is a underlying already designed structure, which is represented by FHIR profile that is available. So we have these use cases for NHCX, and we have designed a FHIR profile for each and every use case. Next slide, please. Oh, I'm so sorry. So when you talk about NHCX for FHIR profile, now here FHIR profiles are designed on the basis of use case. So when you talk about pre-authorization and claim submission, so claim bundle is the profile that you need to refer to, which will cover the information regarding the patient, its demographics, provider detail, diagnosis, then insurance details, and what all services are provided under that encounter for which are required to submit for that claim processing are covered under item, which covers benefits categories and product and services for that claim submission. So likewise, there are multiple bundles designed for each and every use cases. Next slide, please. So as I said before, so base specification is a FHIR comes with the open. It is open specification where there are no constraint. So every element is optional. So in order to have it or mold it as per our mold it to be used for our use case, we have to provide some constraint. So whenever suppose considering a patient, a basic example. So whenever we define or we have a patient in our hospital, so we need to have his identity. Okay, so when you model that patient into FHIR representation of a resource, it has all its elements as optional, but for our use case we need to have some identity for that patient, and that is why we have made patient identifier as a mandatory. So we have added this constraint. Okay, so when you look at each and every profile, there will be some of the cardinality changes. We have added some of the flags which are represented as a must support. You can find all of that information available, how you can, read that profile and how you can consider those elements to be like whether it is optional or mandatory, or whether multiple values are allowed in that element or not. So that you can refer it through the profile itself. So profile reading needs to be done properly, and there are multiple views of the profiles that are available. So key elements table represents all the key elements to define that resource or profile. Differential table tells you about what all differences, what all changes that we have made in order to make that profile, which will highlight only the differences or changes that we have made it. Snapshot table will give you the exhaustive, expandation of that resource, and that is how you can see multiple views of the same resource or a profile. Next slide, please. So let's understand how FHIR structure is represented when it comes to any real world document. So now consider here there is OP consultation note where basic information about the doctors and patients is there, and what all in that encounter, what all chief complaints and physical examination has been done. So that is there on that document. But so whenever you will require to have that human readable document, a hard code document, to map it to the FHIR resource, then that can be happened in the next slide. Yes, so that can be represented with the next slide. So when it comes to ABDM resources, where we need to represent a document as a document which represents a bundle as a document which represents a document artifact. So in FHIR there is a resource called bundle, which allows you to group multiple resources together to form a meaningful document, or to form a meaningful information. So here when we represent ABDM artifacts, so all the bundles profiles are represented with type document. So whenever, and that document will represent any of the single record artifacts. So here consultation note is represented as a bundle of type document, where its composition, whenever you will have, there is a rule in FHIR, whenever you will have a bundle of type document, the first resource should be a composition, which actually sets the context of that document, what all information, what that document is representing. So here a composition resource is actually representing a clinical consultation report, and what all information that composition or that document will contain further is represented by its section. So composition will give you the complete context of that document, and whatever references that are referred in the composition resource are further will be aligned one by one under that bundle. So that's how a bundle collects all the resources which makes a meaningful document with the bundle of type document. Okay, so here what we can see is the consultation, the bundle here is actually giving you the syntactic interoperability that gives a syntax where and what information comes, and place for each and every information. And if you look at the condition resource that is highlighted with the blue color, which actually telling you the actual condition, or chief complaints problem that is noted for that patient with the terminology standards. Here SNOMED city is a terminology notified for a primary terminology. So whenever we are capturing any clinical information through UI or anything, SNOMED city is a primary terminology. So with this standard, international standard use as a primary terminology, we are achieving semantic interoperability. So that's how we are achieving both the form of interoperability, syntactic and semantic. Next slide, please. So when we now let's understand the NHCX artifacts for that are represented using FHIR, considering an example of claim submission. So while submitting a claim, we required multiple kind of information. Okay, there is a claim form associated with it, whatever services that are given under that. Suppose it is an inpatient hospitalization, so what are services are given under that encounter. There must be then a discharge summary associated with it, multiple diagnostics report associated with it. So in order to file a claim submission, we need to represent that data in the claim bundles. So next slide, please. So all of this information can be clubbed together using a bundle. So now here we are not representing a single document. So actually we are having a collection of multiple kinds of information. So whenever you will find a artifact for NHCX, you will find a bundle of type collection, which gives you where a first resource will actually gives the main kind of resource, where since it is a claim bundle, the first resource in the entry will be always claim, and whatever information that is required to submit that claim, to process that claim, will be then accommodated or will be there in the form of other resources. Then procedures and condition that has been carried out for that claim submission under that encounter will be represented through multiple resources. So that is how there is a difference between ABDM artifact and NHCX artifact. Both are bundles, but one is of type document and another is of type collection, based on the nature of that use cases. Next slide, please. So when it comes to NHCX infrastructure, in order to have after onboarding, when you follow one of the use cases, whether it is eligibility or claim submission, for each and every use cases, there is a underlying structure defined, underlying API mentioned, and underlying FHIR defined structure, which is represented by bundle. So as Yagnesh also mentioned, so in the technical document, you will find all of this information. So whatever use case you will be targeting to based on your problem statement, you need to follow that particular structure. Next slide, please. So these are a few of the reference documents or reference website that you can refer to, where we have implementation guides, how FHIR is adopted, which includes information regarding validation and everything, and some of the resources that NRCS provide that might help you, that will definitely help you to solve problem statements. So you can please refer to these all things. Next slide. I think it's over. So let me walk you through. Sadhna, if I can share my screen just to take them through the.
Yes, ma'am. Maybe you can. Do you
Okay,
want to share your screen now or for the data?
Yes,
then?
yes, I will share my screen.
Okay. Yeah.
Is my screen visible?
Yes, ma'am.
So here you can find the the FHIR implementation guide for ABDM. So in which you will have under ABDM profiles all the artifacts or designs profile for ABDM, and under NHCX profile tab you will get claim artifacts or NHCX artifacts listed down here. What are terminologies that we have defined and that are referred in those profiles are available under the terminology tabs. Each and every artifact has examples populated that you can refer to under example tab. Then after that, let me take you through the NRCS website, where you can find multiple resources like videos, presentations, and implementation guides that you can follow that might help you to go through to solve your problem statements. And let's talk about problem statement 1. So whenever you in order to get on board or to ABDM or NHCX, you need to exchange your data in standardized format. So there are many what we can say existing system that are already there, a lot of historical data that is already there, and being a healthcare data, considering its criticality, we cannot skip that data and we cannot remain that data where it is. So whenever we need to exchange, there is a need to exchange that data of a legacy system over ABD or NHCX. platform, we need to convert that legacy systems data into these ABDM or NHCX format. So our first problem statement covers this use case where you need to develop an open source service that can be a microservice, which can, convert this legacy data into a FHIR compliant, NHCX aligned or ABDM aligned data. So and the expected output is solution that needs to be open source, then reusable component it should be, and which can be embedded into any HMIS application. So considering this problem statement, we have some sample data, and I have downloaded that sample data. So this sample data is actually representing a legacy system data where where extracted information regarding claim submission. Okay, so in first problem statement, you need to populate a claim bundle based on pre-authorization or final claim submission. Claim bundle needs to be populated where or whatever information required for claim submission, whether it is patient demographics, patient encounter, claim related information, diagnostic related information are covered in all of these data. If you look at table, there is a lot of data that you can find, and every data needs to be mapped to the FHIR resource, which is available here, FHIR resource, and you need to actually form this claim bundle. So if you look at the claim bundle, it is a bundle of type collection, and it has a claim associated with it. So whenever you will find whenever you will follow a differential table, you will have all the information of what all information is mandatory, what all information is must support. So accordingly, you need to file that claim based on the information provided in the database. And our first problem statement finds the claim submission is mainly targeted towards the claim submission, whether it is pre-auth or final claim. Let me take you through the third problem statement, where as Yagnesh defined, you need to have a policy. So there is a policy document available. So you need to have that policy document into the computer processable format. For that, we have a insurance plan. So which covers all the benefit, all the details associated with that plan, whether it is multiple coverage with inpatient hospitalization benefits, and benefits, number of benefits under that coverage when it comes to inpatient hospitalization, bed and multiple services that we provide under that coverage and benefits that are listed in that document. So the third problem statement is actually aligned with that. You need to make that PDF document, and you need to map it to the FHIR insurance plan bundle in order to have that PDF document that can be made computer processable FHIR structured document. And few of the sample insurance plan PDF are available here. Okay, let me. So if you consider the insurance, Star Insurance and Alliance, so you have this sample like PDF document of insurance plan here, where you have product name and what type of policy, what all coverages are there, under that coverage, what all conditions are there. So everything that can be everything here can be mapped with the insurance plan object, where insurance plan bundle will be there, which will have an insurance plan. And in insurance plan, if you look at the structure of insurance plan, it is having a name which represents your plan product name, then multiple extensions that we have defined, which tells you about what all exclusions, if at all there are any, for that product. And then what all supporting information required for that product. Then information like its name, aliases, period of active period. Then what all coverages it considers, and under every coverage what all benefits it gives. And to each and every element we have a standard terminology set binding, which you can refer. Suppose like inpatient care management is there, and for that coverage we have multiple benefits under that coverage, which are binded through a SNOMED city value set. So you need to map those, and actual plan related details can be mapped under plan type, and all cost specific details can be mapped here. So that is how you need to convert the actual PDF of any insurance plan product to a FHIR compatible NHCX NHCX enabled insurance plan object ready. And I think second problem statement will be covered by Chandrasekhar. And my part is done. In case of any queries, please let me know. I'm stopping my shares.
Yeah, thank you so much, ma'am. Chandrasekhar, maybe you can share your screen now because you'll also have to do the walkthrough of the data. And any questions we'll take in the end. Or alternately, you can also drop them on the chat box and we'll try to get back as we go along. Over to you, Chandrasekhar.
Okay, thanks Sadhana and thanks Sally. Let me share my screen. Let me know if my screen is visible.
Yes, we can see it.
Okay, yeah. So this problem focuses on extracting the data from a PDF document. So for example, we have a lot of documents, right? Like, let's say lab reports or discharge summary or immunization records usually are exchanged in the form of PDFs, right? Between hospitals or like with the patients, etc. Now for processing, these are like human readable formats, but not machine interpretable format, right? So if you can standardize these, right, into digital formats, especially in FHIR, right, if you can represent in FHIR, the claims can be processed very easily. So this problem is mostly on that, like, so you need to create a microservice or a library which will basically read these PDF documents, especially the lab reports or diagnostic reports, extract the data from them, and then create ABDM compliant FHIR resources, or basically FHIR bundles, right? And some of the key things you need to focus on is that, like, the microservice or the library that you create should be configurable. If you can create configurable services, it would be good instead of like hard-coded services, right? So that they could be reusable across HMIS resources, and also helped by different healthcare systems, right? And you need to make sure you extract all the relevant informations from the lab reports, which so that the FHIR bundles can be created appropriately. So I'll just take you to one of the example. Is my screen visible? I'm sharing a lab report.
Yes, we can see
Yes.
it.
Okay. Okay. So if you see like this, this is a very big PDF file, right? Um, uh, so processing by claim systems, like they have to undergo a human review, which will be very costly. Now, if you can convert this into a FHIR resource, so which is machine readable, right? Then the process can be automated by a lot extent. So especially like when you're trying to convert this document, right? There are informations like who is basically the lab provider, right? Who is basically has done the lab test. So that information has to be extracted. And when it comes to the actual test, right? Before going to the test, there are also informations like who is a patient, what is the age, name, right, etc. You can see over here, and what time is the testing done. So these have to be extracted, and the appropriate FHIR resources have to be created. For example, here a patient resource have to be created, and for the lab, right, probably an organization resource, FHIR resource can be created. And for each of the lab individual tests, let's say here there's a test called acid fast in, right, report. Basically, you take a biopsy and then create it. It says negative. So this is basically a lab test which is done. So you might have to create probably an appropriate FHIR resource, observation resource for this. Right. So there are like multiple pages in one document, so which consists of multiple lab tests. So you need to basically extract all these relevant. Sometimes there could be like irrelevant informations like which need not be extracted, but the core things that needs to be extracted are the lab tests, patient information, etc., which are very much important. Right? And at the end of the day, you create ABDM compliant FHIR resources. For example, some of the ABDM compliant FHIR resources. This is a diagnostic report. Like here you can see like ABDM compliant resources for different medical document types. Let's take an example of diagnostic report. Right? So it's, let's say, composition FHIR resource, which can consist of multiple sections like this. So you might have to extract and then create a FHIR resource which is compliant, which adheres to these particular fields or rules defined in this. So when I say that, you might have to create for example, you might have to create a JSON resource which is of type. So this is one example of a diagnostic report. So which contains, so here you can see, right? 1 second. So this is a composition resource. Here you can different fields, like you can also see patient. 1 second. Okay, I might not be able to show that right now, but this consists of like all the different FHIR resources that needs to be captured as part of a diagnostic report. Yeah. Yeah, I think I'm done with the problem statement.
Yeah. So I think we'll take questions after the other two problem statements are also done. Now I invite, give me a second
Arun
while I
Sharma.
just share my screen again.
Positive, negative, but just that, okay, AI is here to come and it's going to here to stay.
Yeah, are you able to see my screen?
That is the kind of because
Is my screen visible?
Should I start, Sadhana?
Yeah, I'm just inviting Mr. Arun Sharma, who heads Business Excellence at Aditya Birla Health Insurance, to talk us through these two problem statements. So thank you so much for joining us today on such short notice. Over to you now.
Thank you, Sadhana, and good afternoon, everyone. So today I'm going to present two real-world business problems that we deal with daily in health insurance operations. And your challenge is to use NHCX capabilities to solve them. So first problem statement is fraud management and detection leveraging NHCX. So I'll give you some background. So in our current environment, we do have triggers and rules to detect suspicious claims. So however, the reality is this: these triggers produce too many alerts, and when everything becomes a red flag, obviously nothing is a red flag. So this leads to a number of operational issues, like our investigation team gets overwhelmed, investigation costs go up, claims take longer to settle, and customers get frustrated because they are questioned or asked for documents repeatedly, and overall turnaround time becomes longer. So, but even more importantly, the genuine, honest customers and the good hospitals end up getting subsidizing this behavior. Maybe they caught in the same net as fraudulent ones. So, and that is something we absolutely do not want. So, this fraud, waste, and abuse, we call it FWA. So, it increases the total cost of claims. And when claims become more expensive, so premiums go up, and that means honest customers end up indirectly subsidizing fraudulent behavior. So now this is where NHCX becomes a powerful enabler, and it can help us in multiple ways. So I'll describe 3-4 business cases for this problem statement, and you can pick up any one of those, or maybe if you can be creative and probably come up with any other business case also. So first one is we have our FWA model, so fraud, waste, and abuse model based on our own data, so which is limited obviously. So NHCX has a lot of structured data for all the insurers, all the hospitals, etc. So you can create a much powerful and accurate FWA model. You can build a fraud prioritization engine that reduces false positives and pushes only high risk cases for investigation. And better, if let's say there is a trigger, there should be some explainability be there, that why is the suspicion, what should we look for specifically. So that's one. Second is you have huge unstructured data also. So if same claim gets submitted to multiple insurers, you can red flag that. Third could be when we trigger a case for investigation, investigators ask for documents from the customers and from the hospitals also. So NHCX has integration with ABHA. So we can take some of the documents from there. So it will reduce investigation time drastically, because collecting the documents and probably asking for those documents again and again takes most of the time of investigation. And fourth, you can red flag repeat fraudsters also. So hospitals as well as customers, as you have all the data to analyze. So you have their claims history. You can red flag that this hospital has the tendency to do fraud or probably overcharge, and probably same goes for the customer also. So that's the first problem statement. Now coming to the second. Yeah. So that's optimization of claims processing time and cost using NHCX. So today, regulatory expectations are very clear. Some of you might be aware also that cashless pre-authorizations must be processed in 1 hour and discharge approvals must be processed in 3 hours. And these timelines are from first document received. So I'll just explain it. So I received the first set of documents. If I query, let's say some document is missing, then I'll wait for that document. And then let's say if hospital takes 3 hours or customer takes 3 hours to send that document, that required document, I'll bust my TAT, because my TAT should start from the first document received. So if you ask any query, ask for missing document, TATs get longer. Plus our aspiration is to go far beyond compliance. So nowadays, nobody would like to wait for 3 hours. So we want to move towards straight through processing, or if not straight through processing, few minutes claim adjudication time. So there could be many business cases here also, and I'll explain again 3 or 4. First one is we get the claim intimation via hospital portals. So hospitals scan the minimum required documents and send to us, and then we have queries. We ask for more documents, and that takes time, which is crucial for the customer who is waiting to get discharged from the hospital. And it takes sometimes many number of hours. So our TAT is 3 hours. If we query, then it goes much beyond 3 hours also. So NHCX has integration with ABHA, so it can help us in providing the required documents quickly. So 2 things. One, what is the list of required documents for that type of claim? That's one. And second, that document must be available with ABHA. So we should get it quickly. Second business case could be we need to check for overbilling from hospitals. So we compare bills with agreed tariffs. So we have tariff agreements with hospitals, but obviously we do not have tariff agreement with all the hospitals. So we can't compare bills of a large number of claims with standard tariff. Now NHCX can play a big role here. So they can highlight the overbilling for the procedures, etc., based on their huge data set for various hospitals. They can also estimate the billed amount based on hospital type, city that hospital is in, or ICD. That will be huge help for insurers. Third business case could be we adjudicate the claims based on ICMR guidelines. And that's the major friction between insurers and the hospitals. Because these are just the guidelines and not all the hospitals and all the doctors agree with them. So based on the huge data for various hospitals and claims, if NHCX could come up with a standard treatment guideline that most of the hospitals agree, it could lead to huge effort and cost reduction for insurers as well as customers. For example, let's say two specifications I would give. A procedure diagnosis consistency checker that validates whether the treatment makes sense for this ICD or not medically. Second could be a length of stay appropriateness. So some kind of engine that tells me what should be the length of stay for this kind of ICD, this kind of sickness, and it flags overstays. Fourth business case could be NHCX can help in deeper penetration in automated claim intimation for cashless. So we use hospital portal to receive those cashless, and not all the hospitals use the same portal. So there are many portals in the market. So not necessarily my portal only would be used by that particular hospital. And in fact, many hospitals do not use any portal. So they send the claims on emails. Even the hospital, let's say the hospitals, even though using portals, some of the claims, 1/3 of the claims they send via email still. Probably depends on user to user. So you can help us in improving compliance to send the claims via the portal rather than manually. So those are your two problem statements with many business cases. So please focus on showing how NHCX can transform the way we detect fraud and we process the claims. I would say all the best. I'm excited to see what each of you will build.
Thank you so much. Thank you so
And
much,
open
Arun
for
sir.
question.
Yes. Yeah, just I think like sir had mentioned, am I audible?
I can hear you, yes.
Yes, okay.
Yes,
Yeah.
Sanjay.
Yeah. So like sir had mentioned, I think these business cases is broad and up to the interpretation of the participants as well. We will just quickly cover the hackathon guidelines. I invite Farooq sir from NHA to for this, and after that we'll take some questions. Farooq sir?
I'm not good there. Might be possible.
Because ACDHA is the very school of biosciences and that's what. So I think he would be.
Give us a second.
Yeah. Sorry, actually, I was not able to unmute.
Yes, sir. I sorry, I hadn't provided the access. Yes.
Yeah.
Yeah. Can you see my screen?
Yeah. So good afternoon, everyone. So here are few of the simple guidelines for doing the evaluation of the artifacts, whatever you guys will be submitting. So this all we need from you guys is that clearly a readme.md file, or maybe it can be a text file also. So we prefer to get the details through a readme.md, so which will give a small scope of the solutions, including an architecture, a very, very high level architecture, setup instructions, dependencies, if any, and the implementation details. So that is one of the must document which you should prepare during the time of submission. And there has to be an end-to-end video demonstration of the functionality. Okay. So in that video demonstration, so probably you have to show the extensive workflow, highlighting the key features and the functionalities. And if you feel that if your video cannot be accommodated in less or equal to 5 minutes, so you can create a multiple chunk of the video. Okay. So, and apart from this, you have to freeze the code and with with the MD hash, so that we can see that at this point of the timeline and the timestamp, so you have frozen the code. And that code also need to be zipped and send it to us. So this means that in essence, you have to send us 3 artifacts. One is the readme.md file, as well as video or videos, and as well as the code base in the zip format. So can you go to the next slide? Yeah. So see what we will do is that Sadhna, let's do one thing. Let's go to the diagram now. Show them the diagram. It will be better.
Yeah. Give me 1 second. If you have the document open, you could share your screen, sir.
Yeah, I can share that. Hold on. Just hold on. Can I share it?
Yeah.
Every point मुझे ऐसा लग रहा था कि 5
Yes, we can see it, sir. If you can zoom in, yeah.
Yeah. Are you able to read it? Is it legible?
Yes, sir. A bit more would be helpful, but we are able to
It
read
is
it.
going out of the.
Yeah, this is fine.
Yeah.
Yeah. So this part, like already I have described, like the artifact should be in the form, scope, high-level architecture, tool set used should be in the README file, and there has to be a video, and then there has to be a source code of the zip file. And along with that, what you can do is that you can upload these artifacts into any of the Google Drive of your choice, and then share that link with the NHA. So NHA will be providing you with a Gmail ID. So in that Gmail ID, you can share this. So what will happen is that we will access your Google Drive link, and then we will download all the all the artifacts. And once we confirm the downloading of all the artifacts, so probably you can go ahead and parse that. Okay. And after that, so what will happen from that Google Drive, we will be pulling it to our own document repository, and from there we'll start doing the initial screening, and then what we'll do, we'll do the shortlisting. So if you are shortlisted, then the NHA Hackathon team will invite you for giving you the demo on your environment. Okay. And then jointly we'll conduct the demos, and then based on the demo, there will be a final evaluation. So that is the process. So if there are any questions, so I'm happy to take those questions.
Okay, Farooq sir, I think you can stop sharing. We'll take all the questions together at the end.
Okay.
All participants can also note that this will be provided on the website. It will be made available with clear submission guidelines to you. Now I invite Dr. Ajay Nair to share his remarks. And Dr. Ajay is a volunteer with NHA and has been involved with the NHCX and the evolution for a long time now. So Ajay, I invite you can take over. Yeah, give me a second.
Thank you, Sadhna. Hi, all. I won't take a ton of time. Thank you for sitting through these presentations. I just wanted to say a couple of things. One is that we are at the intersection of the payer-provider ecosystem, which is one of the biggest factors that will drive the evolution of the health system in India, not just for insurance patients, but for everybody else, because insurance sets the tone for it. So one is to remember that. The second is to also very clearly state that the NHCX is not a static entity. It is not a static protocol. The idea with the NHCX right from day zero was to have it be something that evolves with the need of the market and need of the industry. So it's very important that you are not limited by what the NHCX does today. There's a lot of smart brains on this call and in this hackathon. We would really welcome suggestions from you on a direction of evolution of the NHCX, features that you think can be added, use cases that can be added. But the idea is to keep evolving this together. And at the end of the day, it has to work for the patient, it has to work for healthcare, and it has to work for the insurer. So always keep that in mind. And I just wanted to make this brief remark and then hand it back to Sadhna. Thank you, Sadhna.
Yeah, thank you so much, Ajay. I think with that, we have covered everything that we wanted to sort of take you through. Thank you so much and for your patience and for just sticking around the entire time. Now I'll open the floor to questions. I see that some of you have already put some on the chat. I'm just going to allow all participants to unmute yourselves as well. So if you have any questions, please raise your hand and we can take those up for the next, say, 10-15 minutes. I see Pranay, who's raised his hand. Please unmute yourself and you can pose the question to everyone present.
Hello everyone. Just wanted to ask that for the ideathon problem statements, we just need to provide the whole ideathon with the whole idea with the business plan, or also we need to provide the code for the prototype.
Pranay, you just have to provide, I think we've mentioned on the website also, we require a clear business case. You don't have to provide the code for how this can be implemented, but you will have to provide a very clear definition of the problem, the approach, the business value or the business model with which you've arrived that this can unlock potential. The details are on the website, but yeah, you don't have to submit the code. It is just a business use case.
Okay, thank you.
Anyone else? I see Smith, you, Smith or Sumit from RQSoft, you have mentioned, yeah, in submission guideline, it is written to upload the code on GitHub. In the call, it said the code needs to be on Google Drive. So Google Drive is for the recording, the video demo of the solution of you executing it end to end. And the GitHub will be for the code base. Farooq sir, please correct me if I'm wrong. But this will be the submission guideline will also be updated to ensure that there is no doubts or any sort of errors in this process. But as part of your submission package, we require the code base uploaded on GitHub along with a very clear README and a video demo. The code is definitely needed. It has to be uploaded on GitHub. Any other questions? Tumula Jagan, I see your hand is raised.
Yeah, last time someone said that the code should be zipped and linked to Google Drive, but you're now saying that it should be uploaded to repo.
No, so like I just mentioned, the README and the video will have to be zipped and on the drive, but we will publish the submission guidelines clearly on the website, so there'll be no confusion regarding this.
Yeah, and also for problem statement too, I have one doubt.
Yes.
So in the desired output, it is said that the microservice that converts diagnostic report or discharge summary to a FHIR profile. So should we submit that microservice only, or should we also include that in claim bundle, and that use case also should be there in the submission?
Sayali ma'am, you can get into this in more detail if that's okay.
I guess only one problem statement they need to solve, right?
Yeah, it is. I mean, I think you're speaking about problem statement two.
Yeah.
Yes. The HI type conversion is what you're talking about. I think in an ideal, you can pick, for instance, if you're picking diagnostic report, you will create that in the structured HI type, and then you can include it either in a pre-auth or a claim bundle.
Okay, so we also need to do claim bundle creation also in the solution.
Yes, I think so. Yes.
Sarna, just give me problem statement 2 you're talking about, right? So
Yeah.
it is just a like HI type to be converted